Hello, everyone. In this video, I will talk about some differences between AMC10 and AMC12. This talk consists of 3 parts. In the first part, I will mention the major differences, including topics appear only in AMC12, but not in AMC10. In the second part, it includes some minor differences. There are topics that are fully required in AMC12, but just partially required in AMC10. Lastly, in part 3, I will talk about topics that are fully required in both tests. However, AMC12 requires a deeper understanding. Now let's come to part 1, the major differences. The following 3 topics appear only in AMC12, but not in AMC10. The first one is logarithmic functions, and the second one is trigonometry. Lastly, the third one is complex numbers. In the next few pages, I'm going to mention their typical styles based on examples. The first topic is logarithmic functions. An AMC12 question could be a basic arithmetic problem, like the following example shows. To solve this problem, students are required to simplify the given expression using arithmetic properties of log functions. Logarithmic function can also be combined with other topics. For example, geometry, number theory, and the probability. Example here shows a geometric problem on the graph of the natural log function. It concerns a quadrilateral whose vertices are all on the graph. To solve this problem, students are required to know not only the arithmetic property of log function, but also some geometric techniques. The second topic is trigonometry. It includes many identities. A typical trigonometric question can be a problem based on certain identities. Here's one example based on the difference formula of cosine function. Trigonometry has a wide application in other topics, including equations, geometry, and complex numbers. Let me show you one example on geometry. Now we have a triangle with integer side lengths. The cosine values of all 3 angles are given. The question asks for the smallest parameter. Here, students are required to use law of sine to find the ratio of 3 side lengths. The law of sine is an important theorem in trigonometry that solves geometric questions. There's another theorem called law of cosine, which is also very useful in geometry. The third topic is on complex numbers. It still has basic arithmetic questions and advanced problems related to other topics. Let me first show you one arithmetic question. Given 5 complex numbers, after taking the 5th power, which results with the largest real part? So this problem tests students' understanding of a complex number in its algebraic structure and geometric meaning. In particular, it is very helpful if student knows the De Moivre's theorem. As already mentioned, complex number could appear in other topics. For example, it is closely related to trigonometry in terms of Euler's formula. It is also used to interpret certain geometric relationships on plane figures. Furthermore, a complex number may appear as a solution in polynomial equations. Here, let me give you one example concerning the roots of a polynomial with real coefficients. This problem is based on the relationship between the conjugation of the whole equation and the conjugation of its solutions. So these 3 topics mentioned above, logarithmic functions, trigonometry, complex numbers, they appear only in AMC12 and not in AMC10. Now let's move to part 2, some minor differences. In this part, we consider certain topics that are fully required in AMC12, but just partially required in AMC10. The first one concerns conic sections, including circles, ellipses, parabolas, hyperbolas. AMC10 only requires the standard formula on circles, parabolas, hyperbolas, but AMC12 requires the understanding of intrinsic geometric interpretations for parabolas, hyperbolas. As for ellipse, it never appears in AMC10, but AMC12 requires a full understanding. Next, minor difference is the extreme value problems. It is much easier in AMC10 than in AMC12. Another minor difference I'd like to mention is the requirements on algebra. In terms of algebraic equations or algebraic functions. Of course, there are more differences. In this video, let me simply focus on the above 4 aspects. The first one, conic sections. Here, I'm showing you an example from AMC10. It is a geometric question on a parabola. We can see this parabola is given explicitly by a standard formula. But in AMC12, parabola may appear in terms of intrinsic geometric interpretation using focus and directrix. Here I'm showing you another example from AMC12. To solve this problem, students must understand the meanings of focus and the directrix. Next one, topics related to ellipses. AMC10 only requires the circles, which can be regarded as degenerate ellipses. It is quite common to have questions based on circles in AMC10, like the following example shows. The general ellipses only appear in AMC12. It may appear in terms of standard formula. Like this example. AMC12B 2012, question 10. The formula is given as x minus 4 squared plus 9y squared equals 81, which is a standard ellipse. The ellipse may also appear in non-standard formula. Like this question, AMC 12B 2004, question 21. There, the formula is quite complicated. 2x squared plus xy plus 3y squared minus 11x minus 20y plus 40 equals 0. Geometrically, this corresponds to a tilted ellipse in the first quadrant. It's quite general. Also, ellipse may appear in terms of intrinsic geometric interpretation, like the following quoted question shows. The definition is based on focus. Now, let me briefly mention extreme value problems. Here's one example from AMC10 this year. Students are asked to find the minimum value. If one opens these squares, it is quite easy to solve this problem. These two terms cancel each other. The minimum value is 1. Basically, we take both xy to be 0. The minimum is obtained. The next example is from AMC 12. It's much more complicated. It investigates points on a certain curve in coordinate plane. The question is to find the maximum value of certain quadratic expression. To solve this problem, students need to know the corresponding geometric meanings and use some algebraic techniques. This is not as easy as a AMC10 problem. Finally, we consider the requirements of algebra in both tests. AMC10 may have some algebraic functions or algebraic equations. Usually, they are expressed explicitly in terms of formulas, like this example shows. The function is given by a formula. As for AMC12, such question may have more complicated structures. Let me show you one function from an AMC12 test. It is difficult from many aspects. For example, it is a two-variable function, and it's defined recursively. And it is piecewise function. Moreover, it involves some notation from number theory, like the remainder here. Okay, these four aspects we mentioned above are the minor differences between AMC10 and AMC12. In part 3, we consider same topics required in both AMC10 and AMC12. As we know, every year, there are some questions appearing exactly the same in both tests. But in this video, I will just focus on the cases with different problems. For the same topic, AMC12 requires a deeper understanding as expected. Here, I'd like to show one typical feature, that is, some difficult AMC12 problems can be decomposed into a couple of similar AMC10 problems based on certain sequence. Here is a picture to show such structure. In the next few pages, I will explain this idea by using some examples. They are all geometric problems. I chose them because we can use pictures to demonstrate the relationship. But this kind of idea also applies to algebraic questions. Let's see a typical AMC10 geometric question. Here we have a rectangle ABCD. 3 points E, F, G are on 3 sides with prescribed locations. Connecting AG, AC, and EF produces 2 intersections, P and Q. The question here asks for the ratio PQ over EF. There are different approaches to this question, but essential idea is to use similar triangles and their common ratios based on some algebra. As a contrast, we shall see another problem from AMC12. Here, we have a square with diagonal BD connected. Given Q1, the midpoint of CD, we connect AQ1, which intersects BD at P1. Next, P1 is projected to CD and produce the point Q2. Then connect AQ2 and intersect BD at P2. This kind of a process repeats infinitely many times, creating 2 sequences. One is the sequence of Q's on the side CD. The other is the sequence of P's on the diagonal BD. Accordingly, there is a sequence of triangles, DQI, PI. The question here is to find the sum of their areas. The point I'd like to make here is each step in above sequence of operations is actually a very typical scenario in AMC10. In this problem, they are linked consecutively to make a decent AMC12 problem. In the second set of examples, let us see geometric problems on circles. This problem is from AMC10. As shown in this picture, we have 2 circles tangent to each other. 2 common tangent lines are drawn. A hexagon is created with vertices from tangent points and centers. The question here is to find the area of this hexagon. This is a very typical AMC10 scenario concerning tangent relations among circles and lines. Geometric techniques like Pythagorean theorem, cut and paste method are usually very helpful. To see the difference between these tests, here we see another example from AMC12. It is also based on tangent circles. As the picture shows, we see many circles here. They are linked consecutively via tangent relations. In fact, those circles are in a sequence of similar steps. At the beginning, there are only 2 tangent circles with a common tangent line. Then a new circle is created to be tangent to all of them. After that, in the next steps, each new circle is created to be tangent to 2 consecutive circles from previous layer and this common line. If such process keeps going, infinitely many circles are created. Of course, in this particular problem, we just consider 7 layers, including the beginning 2 circles. The question here concerns the radii of all these circles. Notice that the scenarios from each step are very similar. That is, we have 2 tangent circles with a common tangent line. Then we draw a new circle tangent to all of them. Each such single step can be regarded as a standard AMC10 problem. In the third set of examples, I'd like to briefly mention coordinate geometry related to rotations. In AMC10, all rotations, either clockwise or counterclockwise, are always of 90 degrees. Here is one example. In contrast, the rotations in AMC12 are more general. In particular, the angle of rotation can be any value. Sometimes it is even composited with additional operations like dilation. One example is here. We have a sequence of points in coordinate plane defined recursively. The recurrence relation here is based on a rotation of 30 degrees as well as a dilation. These 3 sets of examples illustrate how a AMC12 problem deepens the difficulty based on AMC10 problems. Given the limited time, let me end the part 3 here. As an appendix, let me introduce you a reference on AMC10 and AMC12. This is a book titled A Tour Guide of Pre-College Math, Level B. It is written by Morningstar Institute team. This book covers all topics and techniques required in AMC10 and AMC12. It can also be used to prepare for AMY test, especially for the first 10 questions. This book is open to public. You can download a free PDF file from Morningstar Institute web. Here's the link. The following picture shows its cover. All right, these are all messages I'd like to share in this video. Thank you.